Sure, and just a little backup, we're going to do Lesson 8.2, which in my opinion, again, is almost as easy as Lesson 8.1. Lesson 1, we were adding and subtracting, so we just basically combining like terms. We're going to move on. We're going to multiply a polynomial by a monomial. That means we're going to multiply a polynomial that has many terms by just a one-term polynomial. We do this by using the distributive property. Here's where we get to use the distributive property because it is separated by a sum or a difference. So we take this out front and we multiply by each term inside. So remember our product rules for exponents and variables. So like here, 3x and 2x squared, that's a 3x to the first. So 3 times 2 is 6. And then we are multiplying powers with the base of x. So we keep the base and add the exponents. That'd be 3. And then 3 times a positive 8 is a positive 24, and keep the base, add the exponents, and that becomes 2. And then 3x times negative 1 is a negative 3x. And there you have it. All right, here's another one up here, a little bit longer because there are 4 of them in there. Let me zoom in a little bit. So we've got a negative 6d cubed. Watch your positives and negatives here. In this one, we're going to see it kind of unfold for us. When we have a negative 6 times a positive 3, we have negative 18. D to the 3 plus 4 is 7. And then we have a negative 6 times a negative 2. That gives us a positive 12. D to the, keep the base, add the exponents, so 6th. A negative 6 times a negative d, so a negative times negative is positive 6, and then d to the 4th. And last but not least, negative 6 times 9 is negative 54, d to the 3rd. There you have it. Shouldn't end up with any like terms, but always double check towards the end and make sure that you're okay. All right, so then what happens when we have 2 things? Okay, so we're taking it a step harder. We are going to distribute, or we're going to actually have 2 multiplication, and then we add them in the end. So you see how this is a binomial multiplied by 5b, and this is a binomial multiplied by 4. So my step would be to distribute both of them first. So this would be 10b squared, because we have 2 b's. And then negative, because 5 times negative 4 is negative 20b, plus, and now I'm going to do this one over here. So 4b squared minus 24b minus 12. And now that I've distributed to get rid of the parentheses, I'm going to look and make sure I have, if I have like terms, I combine them. And I do. I've got a 10b squared and a positive 4b squared. Remember our largest exponent, if they're all the same variable, the largest exponent wants to go first, and a negative 20 and a negative 24 is negative 44b, and minus 12 in the end. All right, let's try another one. That's the example in the box here. This is a big one, and be careful. So we're distributing the 15t to both of those, and then we will distribute a negative 2y to both of these. All right, so we have 15 times 10 is 150. I have a t to the 6th. I'm going to go ahead and write that first, and then y to the 3rd. That still stays there, but it just stays y to the 3rd. And then we have a 15 times 5 is 75. 75. T to the 2nd, y to the 2nd. All right, now I'm going to go over here. Now this is a minus 2y, so I'm going to treat that like I'm distributing a negative 2y. So I get a negative 2, and I'm going to go t squared, y squared. Now, could I have put the y squared first like they have? Absolutely. It doesn't matter. I like to go in alphabetical order. And then negative 2 times 4 is negative 8y to the 3rd. Okay, now we have to look very carefully to make sure these two right here are like terms because they're both t squared y squared. So I have 150 t to the 6th y to the 3rd. I have 73 t squared y squared, and then minus 8 y to the 3rd. So the answers are going to be a little bit ugly here today. I guess I wouldn't say ugly, but you know, we're going to get some big numbers, and that's all right. Okay, moving on to word problems. The distributive property, multiplying monomials by polynomials to solve problems. Okay, Jenny pays a fee of $75 to rent a car. She is charged an additional $15 for each weekday and $20 for each weekend day she uses the car. Jenny rents the car for 7 days, where W of those days are weekdays. Okay, this one's a little challenging. So if W equals weekdays, then what equals weekends? And you don't actually need a separate variable. I know that the total number of days is 7 and W is weekdays. So weekends would be 7 minus W. That's tricky. We're going to put that in parentheses. So the charge, or the cost, I'm going to use C to represent cost, is $75 plus it's $15 for a weekday, so that'd be 15W plus $20 for a weekend. Now here is 20 times 7 minus W. So we can simplify this a little bit because we can distribute this 20. So we've got 75 plus 15W plus 140 and then minus 20W. And now we can combine like terms. So 75 plus 140